Okay, I'm on problem number 5. I'm going to go to the whiteboard, and I'll try to do it. All right, so let's go to the whiteboard. Give me 1 second to get to the whiteboard. Push this up. This is number 5, right? Let me just get to number 5. F of x is equal to x4 minus 4x cubed minus 23x squared plus 54x plus 72. All right, looking for the nature of the roots, we use the Descartes rule of signs. Plus, minus, minus, plus, plus. All right, let's think about that. We're looking for the number of sign changes. And how many sign changes again? We get 1 here, and we get 1 here. So S equals 2. What do I write down? S minus P. Well, S is 2 minus P equals something. And what does equal? Non-negative even integer. Before I do that, though, I want to point out that this is a 4th degree polynomial, and it definitely has a positive coefficient on the 4th degree. So it looks sort of like this over here. Sort of. I'm not saying exactly. So what could P be? P could be 0, or P could be 2. All right? Now, before I do anything, I want to think about it. And someone says, why do you want to think about that? I think I could probably narrow this thing down. And the way I'm going to do that is I'm going to be looking at numbers. And I want to tell you what numbers I'm going to be looking at. Easy numbers. Right, just on the positive side. So if I pick 0, I would definitely get a positive number up here. It's 72, by the way. And then, I'm kind of looking around, and I realize if I took the number 1 and just plugged it in, it would still be positive. I hope you realize that number 1. But then I start to realize if I start to go to a 2 or 3, I'm going to say if I want to 4, right? And so why am I going to 4? Because 4 looks like it actually might produce a negative number. All right? Now, if I can show it's a negative number, right, at 4, let me put out what I mean by that. I'm going to go to 4. I want to show it's down at 4. So I'm going to do f of 4. Well, this would be 4 to the 4th minus 4 to the 4th. That's 0. Then we'll let this minus 23 times 16 plus 54 times 4 plus 72. All right? Let's write this down. Minus 230. Right, that's 10 times 23, by the way. Minus 230. Let's see, 6 times minus 20 is minus 120, and minus 18. And let's do this. What's 5 times 54? That's 216. By the way, I hope at this point you now know that this thing is negative. It's over here. So what do I know? I know this thing has got to be doing something like this. So right now I know this can't be a right answer. There's no way it could be, because this thing's got to come back up again. And why is that? It's a 4th degree polynomial. I'm seeing it. So now I can narrow it down to that. Now you might say that's additional work, but it's still work. I want to do that work if I can. Now let's rotate it. And what do you get over here? F of x. No, not f, doing rotation, right, about the y-axis. What does that give me? x4 plus 4x cubed minus 23x squared minus 54x plus 72. Let's go to town. Plus, plus, minus, minus, plus. All right, let's take a look. There's one change here, and there's going to be one change here. All right? So what's S? S is 2. put this down. S minus P equals 2 minus P. This must be a non-negative even integer. So what could P be? P could be 0, or P could be 2. Well, you know what? This is a rotation. I realized that. I took the negative roots and I made them into positive roots now. So it's really the same type of deal. I'm still looking at a graph, and I want to see if I can do it. We're looking at this graph now, though. So I hope you can agree we're still going to get, at 0, a positive number there, 72. And I don't know, let's take a look at it. And I'm kind of looking at it. I wanted to just see what would happen at 1 if I put 1 down there. So what would that be? And by the way, I'm plugging it in here. What would you get? You get 1 plus 4 minus 23 minus 54 plus 72. All right, okay, it's kind of close. I realize that. So what do you get? 5 minus 77 plus 72. Well, that's definitely above the 0. Hope you can agree with that. All right, so at 1, it's still positive. Let me try 2. Let's put that down. We're at 2 now. Let's see what happens. What's 2 to the 4th power? 2 times 2 is 4, 8, 16. Plus 32 minus 23 times 4. Whoops, got a little excited there. Minus, we're trying 2 by the way, 54 times 2 plus 72. All right? That doesn't look too bad to do. What do you get? 48 minus, that's 80 and 12, 92, minus 108 plus 72. This is definitely negative. What do I now know? Here it's negative. So I know this curve, the rotated curve anyway, goes through here. This is not a possibility. So now I'm ready to answer the question. Right, did I have to do additional work to do it? You're right, I do additional work. What do I have? 2 positive roots. And by the way, this was the root of, this is the analysis on the negative roots. It was rotated. So remember, whatever these roots over here, I rotated them from there. And there's 2 negative roots. All right, let's look at the picture. All right, go to that picture. We're on number 5 now. Let's take a look at it. And it's figure 296. I got that right here. And what do I see? Lo and behold, 2 negative roots and 2 positive roots. And we are done. I want to remind you, if you need to reach out to me, my name is Ron Bannon. My email address is Bannon, that's B as in boy, the @ symbol, NNON.US. All right, for the students that are working with my blue area, it's certainly going to look a little bit differently than when I went to the whiteboard, but it still contains the same content. All right, thank you.